All right, let's dive right in. We're going to peel back the curtain on, well, existence itself. And we're going to explore this really simple but kind of elegant idea. What if everything, all of life, in all its breathtaking diversity, was built from just a handful of common bricks?
I know, it sounds a little like science fiction, right? But it's totally not. The unbelievable complexity that makes up you and me and literally every living thing, it really is all built from a universal set of building blocks. And figuring out what those are, that's the very foundation of biochemistry.
So, just like any huge building, it all starts with a single brick. And for us to really get a handle on life, we've got to start right there, with the atoms.
Okay, so at the very center of each of these atomic bricks, you've got a dense nucleus. But the real action, the magic that lets all these bricks connect to each other, that all happens on the outside, with the electrons. They're the ones that decide how everything's going to stick together.
Now, there are a whole bunch of different types of these atomic bricks for sure, but there is one that is truly special. It's the ultimate connector, the absolute MVP, the master builder of the entire biological world.
And its secret? It all comes down to this number, 4. So what's so special about the number 4? Well, for this one particular element, it's the number of electrons it has on its outermost shell, what we call its valence electrons.
And that special element is carbon. Yep, its whole superpower comes from those 4 valence electrons. Because of them, it can form 4 incredibly strong, super stable connections with other atoms, and that lets it create these long chains and complex rings that are, quite literally, the backbone of life.
Okay, so we've got our bricks, and the main one is carbon. But how do they all stick together? Well, that's where chemical bonds come into play. You can think of them as the universe's superglue.
Now, this superglue comes in a couple of main flavors. On one hand, you've got what's basically a transfer. One atom pretty much steals an electron from another. We call that an ionic bond. It's kind of like a thief and a victim. On the other hand, you can have sharing, where atoms cooperate and hold on to electrons together, and that's a covalent bond, much more of a team effort.
So let's zoom in on those ionic bonds for a sec. Take an atom like sodium. It gives away an electron, and boom, it's positively charged. Then you have an atom like chlorine, which takes that electron, making it negatively charged. And you know what they say? Opposites attract. Bam! That powerful attraction between the positive and negative charges is the ionic bond.
Covalent bonds, though, these are all about cooperation and stability. And because the atoms are sharing electrons, these bonds are just incredibly strong. This is the type of glue that carbon uses, and it's the whole secret to building these molecular frameworks that are tough enough to last and support the complex machinery of life.
And finally, there's a third type we need to talk about, hydrogen bonds. The best way to think about these is like fleeting handshakes between molecules. A single one is pretty weak, yeah, but get millions of them together, and they become this incredibly powerful force. They're the reason water is so amazing, and they are literally what holds the 2 strands of your DNA together. No big deal, right?
All right, so we've got our master brick, carbon, and we've got the glue, the chemical bonds, holding it all together. But where does all this construction actually happen? It's time to put the spotlight on the 2 absolute stars of the show, carbon, the builder, and water, which is the workshop where everything gets built.
So just to recap why carbon is such a genius. It's got those 4 valence electrons. This means it can form 4 really strong covalent bonds. And that is what lets it build pretty much anything, from simple little chains to these incredibly complex rings. It really is the ultimate, most versatile Lego brick for building all of life.
Okay, now for our second star, water. And its power, it all boils down to one property, polarity. See, in a water molecule, the electrons like to hang out more with the oxygen atom. This makes that end of the molecule slightly negative, and it leaves the hydrogen ends slightly positive. It's a tiny imbalance, but trust me, this imbalance is everything.
Yeah, that simple imbalance, that polarity, it's not just some minor detail. It's what gives water this whole set of life-sustaining superpowers. It's what makes it the perfect stage, the perfect environment for the entire chemistry of life to play out.
I mean, think about it. Because of this polarity, water can absorb a massive amount of heat without its temperature changing much, which is great for regulating temperatures both in our bodies and on the planet. Also, its solid form, ice, is actually less dense than the liquid, which is why it floats. This protects all the aquatic life underneath during winter. And maybe most important of all, it's an amazing solvent. It can dissolve all sorts of stuff that living things need to, live. It's the ultimate baseplate for our whole Lego project.
So, let's pull it all together. We have our bricks, which is mostly carbon. We have the glue, which are chemical bonds, and it's all happening in the perfect workshop, which is water. So now, let's see how all these pieces come together to build the final masterpieces.
Just look at this progression here. It's a beautiful hierarchy, really. You start with the tiny individual atoms, like carbon. They bond together to make simple molecules, like water. Then those build up into more complex organic compounds. And finally, you get to the absolute crown jewels of biology, the biomolecules. So what exactly are these masterpieces? Well, they're the actual functional machinery of life itself. We're talking about proteins, which do all the heavy lifting, nucleic acids, like DNA, which hold the master blueprint, carbohydrates, which are the fuel, and lipids, which build the walls of the factory. These are the final, incredible, working structures.
And this quote, it just captures the essence of it all perfectly. It's not enough to just have all these different molecules. It's all about how they interact with each other, how they, dance together in this incredibly intricate chemical ballet. That is what gives rise to the phenomenon we call life.
So there you have it. We've kind of walked through the fundamental user's guide to the chemistry of life. We've met the bricks, the glue, and seen the final masterpieces. But it really makes you wonder, doesn't it? If these are the basic rules, what other amazing, incredible things are still out there, just waiting to be built with this universal instruction set?